Okay, so much like the last talk was a bit of a shift from ozone, I'm going to shift a bit and talk essentially about PM2.5, but really about the ammonium side of that as it's related to Cache Valley. We have a well-known problem up there, or we had. Technically, we're in maintenance now. I don't know how long that's going to last, but I want to give you a little history of what we've done with ammonia in Cache Valley and where it still is. So just to reference everybody who maybe is not too familiar with Cache Valley, we're actually bordering on Utah and Idaho. The valley floor is at about 4,500 feet. Peaks go up to about 10,000 feet. We're literally a bathtub with one small outlet on the west side. When we have an inversion, it's about 200 meters or so in above ground elevation. We have a valley floor of about 700 square miles, which means if you do the calculation, you've got about, what is that, 300 billion cubic meters of air within our airshed that it would be polluted. We have no major point sources in Cache Valley. We actually have one permitted point source, but it's not a strong contributor to our problem. The population right now is about 146,000, which surprised me quite a bit when I just looked up this number. When I moved there about 20 years ago, it was 90,000. So it's increased quite a bit. Logan is actually one of the fastest growing cities in the country. Home to Utah State, strong agricultural economy. We are often on EPA's Air Now top worst list for PM2.5. This last American Lung Association report that came out, we were the 7th worst for PM2.5, but that was based on 2017 to 2019 data. Let's see here. Just to give you an idea of our PM2.5 timeline, you can see there, particularly look at the lines in red. The dashed line represents the 3-year averages. The solid line is the individual 1-year 98th percentile values. And you can see in 2021, we are below the standard, just barely. And so a bad winter could put us over the edge. I think this last one, we only had one exceedance. We were close. Of January and February, I think we had something like 24 yellow air days. So we still have potential problems. So what I want to do is tell you, maybe, I should just use this one. Nope. Use this one. About our PM2.5. And in very broad terms, like I tell my students, PM2.5 is made up usually of about 5 different classes of compounds. And through much research, you can see all the dates on the top of there, we know that particulate matter in Cache Valley is around 75% ammonium nitrate. So if we want to control it, we have to go after the ammonium nitrate. And further, on high days, the ammonium nitrate can be as much as 80 to 95% of our particulate matter. So that's where we need to go. So we've done a lot of work on ammonia in the Cache Valley, and I'm just going to say, look at all the stuff we've done over the years, including mobile source measurements. And then this last winter, I had a chance to revisit some of our measurements, and that's what I'm going to end up telling you about. But I want to step you through this a little bit. What's the history of ammonia in Cache Valley? Well, the earliest measurements or non-measurements were part of the NADP program, where they looked at ammonia in rainwater, essentially in snow. And if you look at that map there, we're green, we're good. Problem was there was no measurement there. So the measurement came in 1989. Was the first NADP measurement. And if you look at that, all of a sudden Cache Valley pops up as a seemingly high number in the rainwater. Well, I came to Cache Valley in 2000. One of the first projects we did was look at ammonia and various other ions for basically an 18-month period. And what I wanted you to look at is the 2 extremes there. Those are the wintertime periods. You can see the gas phase ammonia at this happens to be the Logan downtown site, was around somewhere between 10 and 15 micrograms per cubic meter. And a lot of those peaks then matched the high PM2.5. When we looked at all these numbers, the average annual ammonia was about 8.5 or 8.2 part per billion. And the winter time it averaged about 13.2. So these are really the first measurements of concentration of ammonia in the Cache Valley. This also led us to do a little calculation. Are we ammonia limited or nitrate limited in Cache Valley? So we did an ion balance, and we found out that 95% of the time we were ammonia rich. And that then suggests if we want to control it, we have to go after the NOx site. I'm not going to go into much detail on that, but we were ammonia rich at that one site by a factor of about 2. If you look around the rest of the valley, we were actually ammonia rich by a factor of about 6. So lots of ammonia up there. That prompted us to get involved with NADP's Ammonia Network, where it's actually measures gas phase ammonia averaged over 2 weeks. And if you look at this graph from 2012, which was the first one we were actually involved with, Cache Valley, and there was a site established in Salt Lake, we're one of the red. We were all, it just looked like we were higher than most other places in the country except for the Midwest. But that graph, I was always mad at the NADP people because it doesn't really show you how much higher. So I said, well, let's put this in 3D. And I did. And this is what it looks like in Cache Valley, what we call the Ammonia Volcano, because we're 4 to 5 times higher than anywhere else in the country. That's not to say we emit more ammonia, because we don't. We're in the same area of emission rate as Central Valley, California, the Midwest. We just trap it in our bathtub. So just to give you an update, I went and looked at the last Ammonia report, and Cache Valley is still #1. When I first saw that, I thought, oh crap, we're not #1 anymore. Then if you look at that, there's a little line from that big circle that draws you right to Cache Valley. So we did a few more studies. We had chemiluminescent monitors that we put in Logan, and we put it in a rural area. And we looked at what the average concentrations were. And you can see overall, we averaged about 37 parts per billion, much higher in the rural area than in the Logan area, which makes sense. That's where all the dairies are. One of the interesting things we did about that study is we got to look at wind direction out in the rural study, in the rural areas, and how that impacted ammonia. How do you think it impacted ammonia? It really didn't. It didn't matter which way the wind was blowing. If you're not in downtown Logan, you got ammonia coming at you from all directions. So that said, oh, let's put out a bunch of samplers. So we put out a bunch of passive samplers all around the Cache Valley. And so we did see differences in the summer and winter. There are obviously hot spots, and to nobody's surprise, those hot spots are associated with the agricultural industry. We have lots and lots of cattle, depending on which source you go to, about 100,000 head of cattle. We've got about 3 million chickens, various degrees of pigs, horses, sheep, and Franklin and Cache County are the #2 and 3 mink producers in the country. So we have lots of opportunity. Again, you can see the relatively high concentrations. We repeated this study in 2016, and we had a finer resolution of our passive samplers and much, much higher concentrations, upwards of 150 parts per billion in that particular winter. But again, centered in what I know that well, I'll tell you, that's where a large poultry facility is. No, not a big secret. So then as part of the Utah Winter Fine Particulate Study, we got to use a real-time Picaro instrument. And this was in just off USU campus. You can see there's very strong patterns temporal patterns to the PM2 or to the ammonia, really tied into inversion events. When the inversions kick in, the ammonia goes way up. During those 10-day inversion events, we averaged about 29.4 part per billion. And during a non-inversion events, it was about 10 parts per billion. But also, once again, it matched PM2.5, just like you would expect it to do. Anytime there was enough nitrate, it formed PM2.5. We also put out passive samplers, except this time we used 25 passive samplers, so it could really get finer detail. And so there you see that map. Again, the hot spot right there near a poultry facility. The other hot spot up in the upper right-hand side is a second poultry facility. And then the stuff down around the bottom right-hand side, there is a cattle feedlot there, as well as that is also a hot spot for mink facilities down there. One of the things I want to point out, and I won't go into this in too much detail, and this goes to some of the talks we've had earlier, science helping policy. Recently, the DAQ had a regulation presented to us that they wanted to declare ammonia a non-precursor to ammonium nitrate, meaning that we know you have to have ammonia to get to ammonium nitrate, but because it was in so much excess, there was no point in regulating it. And so Our previous study suggested that the Cache Valley was ammonia rich, part of the Utah winter fine particulate study. It also suggested we were ammonia rich. You can see all those blue circles there are below that dotted line, which tells you that it's ammonia rich and not nitrate rich. If you looked at Salt Lake and Utah valleys, you can see it starts out a lot of times to be ammonia rich, but then it translates into being a nitrate rich situation as the inversion event goes on. So what we did in this, or what I did actually, to inform the policy is, yes, Cache Valley is ammonia rich so much that there's no point in trying to regulate it, but we can't say that for the Utah and Salt Lake Valley. So that was modified into the regulation that yes, we still need to be looking at ammonia in these two valleys down here in the south. Which brings me down to this last winter, I had a chance to take the Picaro back out and put it out both at the Logan site and the Smithfield site. And I got 2 weeks of data at the Logan site and almost 2 months, actually 3 months worth of data at the Smithfield site. And just show you a quick picture. That's the Picaro on the left. Actually, there's two Picaros side by side, but the Picaro goes outside, is measuring ammonia. And I put this other picture in here for Bo to show him the Smithfield site. I've been standing on the Smithfield trailers there, talking to the kids playing in the yard right below me. When we put this site in, or DAQ put this site in, that was nothing but a field and a dairy to the north. Now it's a very active subdivision. But if you look at the real-time ammonia, the 1 second ammonia data for February anyway, you can see it follows trends, follow inversions, but it's very elevated at times, peaking up to several hundred parts per billion, depending on which way the wind is blowing. It's kind of hard to look at 1 second data, so I looked at 1 hour data, and you can see the ammonia is in green, the corresponding PM2.5 is in brown, red, whatever you want to call it. And again, very high levels, upwards, pushing up into the hundreds of ppb on 1 hour averages. So it's still huge. 16 seconds over. So I'm going to skip to this. The summary conclusion, we're still an ammonia volcano. Even though our population has increased by almost 50% in the time since I've been there, we're still literally #1 in ambient ammonia. So it's real and continuous. This is just the chronological order of the data. You can see it all stays very high. So one of the things I always think about, well, so what? What does this mean? So I took that average ammonia from this last year, assumed the volume of the air shed, took the average concentration during an inversion event, and did the math. And so I come out with 18.1 tons of ammonia in our atmosphere during an inversion event in Cache Valley. And if you further kind of go on to do calculations and assume that household ammonia is somewhere between 2 and 10% ammonia, that would equal about 273,000 bottles of ammonia you could go down to Walmart and buy, or about $500,000 worth of ammonia in our atmosphere during the winter. So I'm done.
Thanks, Randy. I think we have time for one short.
We're encroaching on a break now.
Yes,
right.
no, we are encroaching on a break. So we have time for one short question.
You showed the inversion event in Cache Valley, like the 10-day event, and the ammonia did go down during it. Is there a time when the ammonia
right in
fell?
the middle of that, there was a little period where it's titrated out. We're not quite exactly sure why. That was at the USU campus site, but you're right, it did go down for that section of that period.
So does that suggest sometimes ammonia control could be effective?
It still didn't go down to zero though. Yeah, there's still enough excess that was there.
All right, I think we're gonna end it so people
Yep.
can have a break. We'll see you back at 3:10 for our last session of the day.
Anybody that's curious, I took this out of there. If you want to know what ammonia looks like in your house, there's inside ammonia over 2 different years. And if you have numerous cats, you're up into the OSHA limits.